Hello everyone, welcome back to my channel IAS Commando. So we are doing important topics in quant for Csat. So in this video we will be seeing the permutation and combination for UPSC Csat 2023. Now see, in permutation and combination, a very simple question have been asked in UPSC. Alright, so permutation and combination is a very large topic, but we will be doing it in a very simple format that much that is required for UPSC CSAT. Alright, so first we'll do some concepts, we'll understand the difference between the permutation and the combination, and after that some basic concepts we'll study and we'll directly move on to the UPSC question. So do watch the video till the end so that you can gain the maximum from this. Alright, so stay tuned. Alright, so now first of all, let us understand the basic difference between permutation and combination. So see, we will understand this with the help of an example. So we are taking a case in which there are three men A, B, C, and there are two posts. All right, there are three people and there are two posts. Now from these three people, two people have to be selected to be filled in two posts. All right, so definitely you will use the combination NCR, where N is what? The total number of people. All right, 3, and C is combination and 2. 2 means the total number of posts that are to be filled. So here what we are doing, we are making selections. All right, we are making selections here. So we are using combination here. Now see the same question if it is twisted a little bit. So we have 3 men ABC and 2 men have to be selected, but one has to be selected for the post of the captain and another has to be selected for the post of the vice captain. Alright, so what we are going to do in this case? So here our arrangement also matters. Why? Because let's select AB. Alright, let's select AB. So when we were selecting AB here, so either we are selecting AB or BA, that does not matter. But let's select A for the post of the captain and B for the post of the vice captain. Alright, A for the post of the captain and B for the post of the vice captain. And another arrangement is when B is selected for the post of the captain and A is selected for the post of the vice captain. Alright, so similar AC also can be selected. So A can be selected for the post of the vice captain and C can be selected for the post of the captain. So in this way we are going to get 6 arrangements. Alright, so 3P2 is our answer. So you understand the basic difference that in permutation we were doing selections, and when we are in combinations we were doing selections, and when we talk of permutation basically we are talking about the arrangement. All right, so this is the basic difference between combination and permutation. So let's see some of the basic concepts. So what is factorial? So factorial is the multiplication of all the numbers when we subtract 1 from them. So the multiplication of all the consecutive number when we starting from 1. All right, so factorial 4 is what? 3 into 2 into 4 into 3 into 2 into 1. All right, factorial 4 is 4 into 3 into 2 into 1. All right, this is factorial 4. Now see, 0 factorial is equals to 1. Factorials are only defined for numbers greater than 0. All right, and NCR is equals to 1 when N is equals to R. Alright, and what is NCR? NCR is basically factorial N upon factorial R, N minus R factorial. Alright, this is NCR. What is NCR? Factorial N upon factorial R into N minus R factorial. So this is the number of the combinations that we have. This is how we denote NCR mathematically. Alright, let's move on. So let's see what is NPR. NPR is factorial N divided by factorial N minus R. We know NCR is factorial N divided by factorial R into N minus R factorial. Alright, and what is NPR? Factorial N divided by N minus R factorial. So obviously NPR is what? Factorial R into NCR. Alright, we can write this in this way also, or what is NPR? NPR can also be written as NCR into RPR. So this is the equation for in which we combine permutation and combination in a single equation. So try to remember this. All right. Now there is a MNP rule. What is MNP rule? It is nothing. It is simple logic. What is the simple logic? For example, there are three things, all right, and there are m ways of doing the first thing and n ways of doing the second thing and p ways of doing the third thing. So then there will be so if we want to do all these things together, so the total number of ways in which all these things together can be done is m cross n cross p, all right. So for example, let's see this question. What does the question say? That the number 1, 2, 3, 4 and 5 are to be used for forming three digit number without repetition. In how many ways this can be done? Alright. So in how many ways this can be done? So we don't have to repeat the number. Alright. So the first number can be filled in 5 ways. Alright. The second can be done in 4 ways because the number we have used here cannot be used here. So 4 ways. And the third can be done in 3 ways because the number those we have used here and here cannot be used here. So 5 into 4 into 3. Alright. So this is the application of this MNP rule. So see now this was the case when they were not when they were not exclusive. Alright. They were mutually inclusive. But if the piece of work is like that they are mutually exclusive, then we don't do the product. Alright. Then we just add. Alright, so this is the difference. So let's move on. Now let's see some more cases. See this thing. Number of permutation or arrangement of n different things taken all at a time is factorial n. Alright. So what does this says? That if you want to arrange, for example, 5 different things. Alright. So and you are taking all of them together and you want to arrange it in different ways, so you will get 5 factorial. All right, so like see the word QWERTY. So if someone asks you number of words that can be formed by different arrangement of words QWERTY, so how many words are there? There are 6 words, all are distinct, so factorial 6 will be your answer. All right, so number of permutation or arrangement of n different things taken all at a time is factorial n. Do remember this. All right, let's move on. See now this case, number of permutation of n things out of which p1 are alike and are of one type and p2 are alike of second type and p3 are alike and are of third type and rest are all different. All right, so in such cases what will be our answer? N factorial upon p1 factorial into p2 factorial into p3 factorial. All right, so see this word Allahabad. Now the number of words formed with the letters of the word Allahabad. All right, so how many distinct words you have? You have A, you have L, you have H, and you have B and D. So we have A, L, H, B and D. So we have 5 distinct words. All right, and the total number of letters are 9. So what will be the answer here? So we have 9 factorial. All right, because there are 9 letters, the number of words formed with the letters of the word this, and then A occur 4 times. So we'll divide it by what? 4 factorial. L occurs 2 times. So we'll divide it by 2 factorial, and the rest are all different, so there is 1 factorial. All right, so let's move on to another case. See, our next case is that number of permutation of n different things taken are times when repetition is allowed. All right, so just see this question. This question is saying in how many ways 4 rings be worn in the index, ring and middle finger if there is no restriction of the number of rings to be worn on any finger. All right, so you can wear all the rings on one finger. You can wear 3 rings, 4 rings. All right, so there are 3 fingers. So what we have to do when we are placing a ring in a finger, we have to select a finger. All right, we have to select a finger. So three fingers can be selected in three ways. All right, and we have four rings. So 3 cross 3 cross 3 cross 3. All right, so four rings could be worn together in this many ways. All right, so this will be the answer. So let's move on. Now see next case, number of selection of R things out of n identical things is equals to 1. Alright, so for example, there are 100 identical marbles. So see this question, in how many ways 5 marbles can be chosen out of 100 identical marbles? So everything is identical, so whether you select 5 out of them or 10 out of them, ultimately what you are going to get, you are going to get only marbles. So the number of ways to select 5 marbles out of 100 identical marble is just 1. All right, it is just 1. Now see, same question if we asked in a different manner, the total number of selection of 0 or more things out of k identical things. All right, so that is equals to k plus 1. So for example, there are 100 marbles. All right, and we ask you to select any number of marbles from them. All right, we ask you to select any number of marbles from them. So in how many ways you can do that? So either you can select 0 marble, 1 marble, 2 marble, 3 marble. All right, so how many ways? So if you're including 0 article also, so definitely 101 ways. All right, because you can select 1 marble, 2 marble, 3 marble, and till 100 marble, so and so on, and you have 0 also. So there is 101 ways you can do that. All right, let's move on. See, now the next concept we are going to see, total number of selections of 0 or more things out of n different things. Alright. So total number of selection of 0 or more things out of n different things. Now in the earlier question, when we were having identical things, n identical things, so the number of ways in which we can select 0 or more things was n plus 1. Alright. But now here we have all things are different. So how you will select NC0? So you are selecting nothing, and then NC1 plus NC2 plus NCN. So this is the way. So for example, there are 100, there are balls written some letters on them. All right. So there are balls and every ball is distinct. All right. So in number of ways you can select 0 or nothing. So for example, you are selecting an orange ball and some player name is written on that ball. All right. So for example, if you have to select a basketball, in that ball the name Kobe Bryant is written, and the 100 balls are there in which 100 great players of NBA names are written. All right. So how you will select? So when you are selecting 0, all right. So that you can do in one way, because you are going to select no ball. Then for example, you are going to select a ball on which Kobe name is there. So NC1. All right. And for example, you want to select two balls, one ball with the name LeBron James and other ball with the name of Kobe Bryant. So how you will select, like NC2? So this is the way. So this can go to NCN. So do remember that NC0 plus NC1 plus NC2 till NCN is equals to 2N. All right. So if total number of selections of 0 or more things of out of n different thing, so that will be equal to 2N. All right. And if you are not selecting 0, so you are selecting from 1 to n. All right. So then you are going to get 2n minus 1. It is logical. All right. So notice the difference between the two. When there are n identical things, so the number of ways of selecting in n ways was n plus 1, and in this case it is 2n. All right. And if you are not taking 0, then 2n minus 1. All right, this concept also we have done. Now let's see about distribution. Number of ways of distributing n identical things among R person when each person may get any number of things. All right. So let's see a situation. Let's see a situation. Imagine a situation where 27 marbles have to be distributed among 4 people. All right. So there are n identical things, means 27 marbles, all of which are identical, and that have to be distributed among 4 people such that each of them can get any number of marbles. All right, including 0 marbles. Then for this situation we have n, we have 27, r we have 4. All right, so what will be our answer? That will be n plus r minus 1, c r minus 1, that is 30 c3. All right, which is equal to 30 upon factorial 30 upon factorial 27 into factorial 3. All right, so this is how we do this kind of question. Let's move on. Let's see one more case. So let's move on to the UPSC question first. So see the question, it is very easy. In how many ways different 5-letter words can be constructed using all the letters of the word Delhi, so that each word has to start with D and end with I. All right, so we take 5 places. So here we have fixed D and we have fixed I here. Alright, so let's take this case as one. So now we have left with only 3 words, 1, 2, 3, and this can be arranged in how many ways? Factorial 3 ways. Alright, so we get the answer 6 ways. So this was our UPSC question and it's very easy. Alright, let's move on. Again, the question is asked, how many different sums can be formed with the denomination of 50, 100, 200, 500 and 2000, taking at least one taking at least 3 denominations at a time. All right. So see, they are asking that in how many different sums can be formed. So definitely, when we have to take a situation in which at least 3 denominations are there, so we have to consider multiple cases here. So at least 3 means 3 when we are using 3 denominations, when we are using 4 denominations, and when we are using 5 denominations. Now we have 5 denominations in total. All right, so the number of ways which we can select n different things. All right, so that was n. All right, that was n. So 5 denominations here, number of denominations 5. Using all the 5 denomination, number of sums can be generated is 1. So this is one thing. And when we are using 4 denomination, then what will happen? All right, when we are using 4 denomination, then what will happen? So when you are using 4 denomination, you just have to leave the 1 out. Now how can this one be selected? All right, how can this one, in how many ways this one can be selected? The one number which has to be left out, that will be selected as 5C1. All right, we know we select by 5C1. So 5C1 we know that is 5. All right. So this is when we are choosing four cases, 4 denominations, when we are using only 3 denominations. So let's leave 2 out. Or in this case, see, both the concepts can be used. So let's leave 3 out. So it is 5C2, or let's select 3 of them. So it is 5C3. All right. So 5C3 is equals to 5C2. So that will be equal to 10. So in the first case, we got only one case. This we got 5 cases, and with this we got 10 cases. So there 16 we get our answer. So this was the UPSC question which was asked. Alright, so now you can definitely employ your combination and permutation because you have learned the concept. Let's see the next question of the UPSC. See, in this question, on a chessboard, in how many different ways can 6 consecutive squares be chosen on the diagonal along a straight path? Alright, so let's see this with the help of a figure. So see this, alright, this is the diagonal, and how many diagonals can a chessboard have? Only 2 diagonals. One diagonal is this, which can go through like this, and one diagonal is this, which is going through like this. And what it is saying, in how many ways 6 consecutive squares can be chosen. Alright, so let's see, choose 6 consecutive squares. So we are choosing this 6 consecutive square. So 1, 2 and 3. Or what you can do is you can take 6 consecutive square as 1. All right, and now there are how many squares? 8 squares. So how many squares are left? This you are taking as 1 plus 2 more left. All right, so in factorial 3 ways you can do. So that will be equal to 6. All right, that will be equal to 6. So I think 6 will be your answer. All right, and if you are doing like this way, so here also you can do like you are getting this in 3 ways. All right, and 3 plus 3 will be 6. So this is a very simple question which can be done even without the concept of permutation and combination, but still. Now see this question. In using the digit 22333 as digits, how many distinct number greater than 30,000 can be formed? Alright, how many distinct number greater than 30,000 be formed? Okay, so here this is a how many digit number? This is a 5-digit number. This is a 5-digit number. So let's fix 1 3 here. All right. So we are fixing 1 3 here. So now these digits can be arranged in factorial 4 ways. So 4 digits are left and they are to be placed in 4 places. So they can be arranged in factorial 4 ways, but we know we have 2 2's and 2 3's. All right. So we will divide it by factorial 2 and factorial 2. All right, so what we are going to get is 4 into 3 into 2 into 1 divided by 2 into 2, which is 4. So 4 gets cancelled and we get the answer 6. So this is how you can do this question. These questions are very basic of the permutation and combination. So whatever concepts we have discussed in a very short amount of time, only that will be used. All right, because permutation and combination is a very vast topic. So now see what is the number of numbers of the form 0.xy where xy are distinct non-zero digits. All right. So this word, pay attention at this word. It is saying distinct non-zero digit. All right, and non-zero. So there are 9 digits from 1 to 9. All right, 0 we can't include. So we have to fill 2 places. So this can be filled in 9 ways. All right, and this can be filled in 8 ways. Why? Because the number that we have used here can't be used here. All right, so this can be filled in 8 ways. So see, this was our m cross n cross p concept that we have learned. So this comes out to be 72 ways. All right, let's go for the next question of the UPSC. See, now this is the question that UPSC asked. So what it is saying, there are 9 cups placed on a table, arranged in equal number of rows and columns, out of which 6 cup of coffee, 6 cup contains coffee and 3 cups contain tea. In how many ways they can be arranged? All right. So what the question is saying is that we are having 9 cups and out of which 3 cups are tea and 6 cups are coffee. Now we have to arrange them in equal number of rows and columns. So definitely we are going to use this type of arrangement. All right. So we are going to place it in a matrix of 3 cross 3. All right. So let's see how many cases can be there. है ना? So in how many ways that they can be arranged so that each row contains at least 1 cup of coffee. Okay. So let's see. So let's fix this. At least 1 cup of coffee we are putting. All right. So when we are putting at least 1 cup of coffee and there are 6 cup of coffee, so there can be arrangement like this, like 2 cups of tea here, 1 cup of tea here. All right, then another be C and this C and this will be C. All right, so let's see in how many ways it can be done. Okay, let's see the solution here. So what will be our solution? So let's take first this case. Now each row has 2 cup of coffee and 1 cup of tea. All right. So each 2 cup of coffee is there and 1 cup of tea. So this can be done in how many ways? 3 ways. All right. So like if in each row we are fixing 2 cup of coffee and 1 cup of tea. So the arrangement can be CCT, CTC, TCC. All right, these three ways we can do the arrangement. All right, so there are three ways of fixing 2 cups of coffee and 1 cup of tea in a row. All right, we have three ways of fixing 2 cup of coffee and 1 cup of tea in a row. Now these all will also arrangement will differ. All right, so there are 3 ways, because for each row we have to consider, so we get 27 ways if we are using what, at least 2 cup of coffee in one row. All right, and now let's take another. So one row has 3 cup of coffee and the other row has what, 1 cup of tea, and the next row has 2 cups of tea. So in how many ways this can be arranged? This can be done in 3 ways. All right, this can also be done in 3 ways, and this can also be done in 1 way. All right, this is the possibility. Now these rows can be interchanged. All right, these rows can be interchanged, and there are 3 rows. So how many ways these rows can be interchanged and arranged? In factorial 3 ways. So already this case we are getting how many ways? 9 ways, and now we'll arrange this rows also. So factorial 3 ways. So how many ways we are getting? 54 ways. And in the first case we were getting 27 ways, and here we are getting 54 ways. So 27 plus 54 is 81 ways. So this is how you are going to do. So these were the question asked in last 3 years in UPSC of what? Of permutation and combination. And you know, these are very basic things. You just have to arrange, you just have to categorize, and then your answer will come. So solve with utmost accuracy and you can get these questions correct. So all the best to all the UPSC aspirant. Please press the like button, subscribe to my channel, and I'll be posting more and more videos regarding UPSC preparation. Thank you so much.